Hello and welcome back to Poor Man's Electronics Bench. Every now and then I run into something that I can't seem to refuse. In this case it was a pair of worked over, vintage, hi-fi audio speakers, Teledyne-Acoustic Research model AR11s. The sale listing clearly showed they were modified, in at least the manner of having the stock woofers or low frequency drivers replaced by a less than competent person who had no working knowledge of the value or performance of the original drivers and decided to roughly cut the totally inappropriate drivers into place to make these speakers function again. This series of videos will cover my evaluation of, research into, sourcing of, and finally installing and testing a new set of low-frequency drivers, which are not factory equivalents, but will perform much closer to the designed specifications than what was installed. This work will involve modifications to an already damaged cabinet, and I know I will have some purists just loathe and seethe in anger about my planned work, but seeing that these speakers are no longer redeemable into a vintage original conditions, and the proper replacement drivers are on back order, I will have my way with them, making a few changes that I deem are improvements, in order to come out with a working and usable finished product. If you are interested in this content, please feel free to enjoy viewing. Hello, and welcome to the next episode of Poor Man's Electronics Bench. In this episode, I am going to cover the work on my newly acquired, used, treated severely badly pair of Acoustic Research AR11 loudspeakers. I have a penchant for vintage hi-fi audio equipment, mostly because it is usually of better quality than most of the mainstream consumer offerings nowadays. It can usually be had at a lower price than what's available, and also, except for the really high-end stuff, some of the older middle-end stuff is of very good quality, and just if it's repaired or maintained properly, it can still be serviceable 20, 30, 40 years later. These particular ones I picked up pretty well at a bargain off of Facebook Marketplace. Unfortunately, they have been treated very poorly throughout their lives. I don't know if you've noticed, but right off the bat they have a black finish painted to the cabinets, which should be a walnut veneer, which is really unfortunate. One nice thing about them is they are sequential serial numbers, I believe. B17803 and B17804. Now the drivers are going to be a big part of the question. The mid-range and the tweeters seem to be in fairly good shape, except there was an adhesive foam that was stuck to the front of the tweeter panels, the high-range driver panels, and that's deteriorated. The whole covers did not come with the speaker. They were missing, and then there was all sorts of modifications done to the front of these at one point I'll go over. Part of the issue was that the original Velcro stickies for the cover was just kind of like a foam rubber cover, and it had these round Velcros on it that were glued and or stuck with a small staple. I don't know if I can get a view, but there is a small steel staple in each one of these on the middle to help hold it. And unfortunately, those staples, the staples are still in good shape. Those are still in good shape. That was to hold what was a cut foam panel that came with these stock. Apparently, over the years, people had problems with that staying in place, so they added Velcro. They added more Velcro. In some places, and this other one, they added even more larger Velcro in an effort to hold it until the covers, I'm sure, just disintegrated and came apart. And I picked these up at a bargain, knowing that, for one, they're a quality speaker. If the components are working properly and they were all original components, the price I paid for would have been a steal. But you probably noticed some shenanigans going on here. We have replacement woofers that were put in. These are not the stock woofers. stock ones have flat parts cut on the basket, on the front of the basket mounting flange on both sides. It's a little smaller than the diameter, mostly so you can have another, I guess, an adhesive panel. But AR made a quantity of these particular style woofer frames for speakers going all the way back to AR3s. The 12-inch woofers, except for one model, I think it was AR313, that had a totally round basket. All the rest of the woofers throughout the 12-inch woofers throughout the line had a flat portion molded whatever into the outer basket in order to keep the enclosure size down a little bit. Part of the goings on with these is, of course, these are not the correct speakers. They are they look like a plastic cone. The originals are paper. The surrounds are a little smaller, and the foam edge is smaller, and I'm practically positive that these are, seeing the way that they were hacked in here, somebody just put some 8-ohm woofers in here. I'm sure what most likely happened is it's kind of rare to burn the woofers out in these particular speakers. Usually you get the mid-ranges and the tweeters will get burned out. Usually the tweeters take the brunt of the abuse, although on this particular model, since this was a later model line of the Teledyne runs, from what I've read, they've updated the quality in the tweeters, so they don't quite burn out as quickly, but it's still possible. The woofers probably succumbed to the foam suspension rot in the previous owners. Instead, the original owner, because apparently I bought this from like a second or third owner, because he had no knowledge of where the old speaker baskets might have been. These were put in as replacements because the person did not realize that the foam surrounds could be replaced fairly easily, and the drivers probably weren't damaged because of the surrounds riding out. It's really a shame, because even the replacement, the direct replacements made for these, which are not a direct AR factory manufactured part, but there is a company that does make some replacements. They make them to fit everything properly. I'll go over specifications on some of the replacements versus the historical specifications and functionality of the original speakers in certain models. But the problem was, even replacing with the correct foam surrounds at a minimal cost probably would have took, even if he sent it out to a service to do it, would have took less than $100 to do. There would have been no hacking away at any other speakers to try to get them in here to ruin them. There also would have been sounding a lot better. I'll go over some of the research I found on these speakers that makes them fairly hard to substitute, if at all. And then I'll also go over some plans of what I'd like to do in order to replace these with something, because as of now, this is October of 2022, even the direct replacements that are available that would fit and are supposedly within specification tolerances of the originals are on back order, and there's really, the sources that make these, there's really no saying when they might come off of back order. So I'm going to just go over a few other things with these. One thing I've noticed is some peculiarities to them. I didn't notice it at the time because he sat out in my vehicle for a while. These have sort of a kind of a musty, moldy smell to them, which I don't know why. And for some reason, all the way along the seams of the cabinet, there is kind of like a split or a mechanical something where something might have been laid down in water and expanded. There's a little bit of splitting on the veneer on the end here, so worse towards the back than the front, which something like this usually indicates that there was some sort of moisture damage because MDF likes to expand. Most woods do, but especially MDF likes to expand and start to come apart. And for the most part, the cabinets are solid. I haven't seen any other major cracks or flaws in them. The only other thing I have seen is there is one spot in this one where there is some sort of mechanical stress crack. It might have been, who knows, it might have been from the item being dropped. Don't really see that on the other ones here anywhere. We're going to go into the inner guts of these in a bit, but first off I'm going to go over playing with them a little bit. I can't resist to kind of try to do some electrical testing on them to see what kind of quality the components inside, besides the woofer, which I know is going to be a variable. The mid-range and the tweeter wasn't exactly, well, I am guilty of checking them out when I bought them, of course. It'd be a fool not to. They did put out a signal and sweep with a audio signal generator, which I have handy, and I'm going to go over some just general testing that I tried on this with audio signal generator and some meters, and then we're going to also investigate a little bit of newer school testing using a Dayton audio speaker test device and software on a laptop just to get the general health of them before I crack them open. So if you're interested in any of this content, please stay tuned and it will be here shortly. And putting the speaker on its back, I connected a couple of, well, I don't know if they're 16 or 18. It's not going to matter. It's all going to be low voltage stuff. You have switched attenuators on these. I manipulated the switches back and forth a few times. I did, since I'm not into it, didn't put any cleaners on it yet. I'm just going to show you the state on this one too. This one's suffering the same fate as the other ones. It's just got this expansion all the way along the speaker, and it looks like something happened there. So, you know, at this point in the life of this cabinet, I'm not in just keeping them totally stock in general. I'm not going to worry about as much. I'm going to see what I can do to improve their health and then equip them with drivers that might work better for the situation. For the woofer, so I've got a wire hooked up to it, and got a little signal testing bench set up. Might look to be an odd way of doing things, but trying to get things in a cradle here so it's not wonking around as much. Got three devices available to use here. One of which is a B&K Precision Dynascan 3011 2 megahertz function generator. I acquired this thing back in probably the early 80s, and it's been unserviced and in working condition ever since. It's capable of putting out a signal from, I believe, 0.1 hertz all the way out to 2 megahertz in a fairly flat frequency response. Pardon me for moving around a little bit while I'm doing things here. Let me get my wires available. What I'm planning on doing is sweeping the speaker and checking for what would be my impedance resonance points on excuse me, all components involved. Those components would be, of course, the drivers involved and the crossover components as well. If there was any major fault in anything, especially if you go over and compare the one speaker to the other one, it would show up as a major change of impedance doing the sweep between the two units. So what I'm going to try to do is measure and record certain frequencies in order to come up with some documentation, some qualitative. It's quantitative, it's also repeatable, but it's not what you call anything by laboratory standard. I was goofing around with these before. These have sat inside for a couple of days now. I've got a Fluke 83 meter on the left here, reading AC voltages in the millivolts. The function generator itself is capable of, let me move this out of the way here a little bit. The function generator itself is capable of supposedly a 20 volt open signal output. It has a 50 ohm impedance. It can't really drive hard into speaker value loads, but it does give you something. It gives a signal that's reasonably undistorted with a frequency test available. And my other meter that I have there, I'll try to get something behind it to prop it up a little bit. It's an old ICO model 565 volt ohm meter. It's functional and actually works fairly well. It's a good add-on to this to check for peaks, because it's a lot easier to read to view and read a peak on an analog meter than it is to do it when you're on a digital. Digital is so much more fussy. It's so much harder to see that peak and relate it to your digits, whereas on an analog, just watching the needle sweep works well. We're going to go back down to some low frequencies here. What I did is I did make up a little test chart here. I also retested things and elaborated more on a Google Sheet spreadsheet to compare the speakers between the two. I'll show you that a little bit later on what goes up. But this was my first bench and thought of just checking the general health of everything in here. I'm going to go and first off I'm going to go max volume output on the speaker itself. Right now it's going to be a little high and not comparable to things on what I wrote down earlier. But right now across the terminals we have 1 volt AC, which is also coming up. I have my meter, excuse me, mold's getting to me, set for 2.5 volts maximum deflection, and right now it is indicating an AC it's indicating higher than the Fluke 87, about 1.3. I don't know how well the Fluke 87 does at this frequency, but we're going to see this. I checked the 3011, and it is flat within a half a dB or 1 dB from 10 hertz well up through 100 kilohertz. So, and this isn't like a 0.001% distortion meter, and plus the fact that it's being overdriven, it's going to maybe come up with a little second or third order harmonics going through it. Right now we have a solid 1.3 on the ICO and a 1.16 on the Fluke at 28 hertz. Going to hit a resonance mostly from the woofer resonance with the enclosure combined. The woofer measurement I'm doing right now really doesn't mean anything except for the health compared to the rest of the components in the speaker, because those woofers are going bye-bye. So we did hit a peak at about 56, 57 hertz. Actually, it's maybe a little, according to the digital voltmeter, it's more around 1.53. So, like I said, this measurement doesn't mean a lot because it's speaker's going bye-bye. So, I mean, it's not rubbing or buzzing or anything, but even at the low voltage input, but we're not going to worry about that too much. One thing I'm wondering about is the crossover on this device. Now the crossover frequency between the low and the mid-range is listed at 500 Hertz from the research I did, which is really low, and it almost puts the woofer in the category of a subwoofer, and I'll get into that later. Going up through things, see, we've got a little bit of a roll-off on the higher end of the woofers, and then if you notice, we're starting to get a resonance peak. We hit our peak about I want to say 474 or so, right around just shy of 500 Hertz, and that has to mostly do with the crossover handing the signal off to the mid-range. At this point, the mid-range should be taking up to about 800 Hertz or so. We're still rolling off a bit. And what I'm going to do is cover the mid-range with a plastic cup. You definitely notice that most of the signals coming out of the mid-range, it's making a large-scale difference in the output. So we're sweeping up to 2. It's a low signal level, but like I said, no rubbing or buzzing or untoward distortion. So each one of the buttons on this meter gives you, if I push the 10K button, it's about 10K center range, and it's about 50 to 1 difference in range, so this lets me go down to 200 Hertz. And hard to say when. I don't know what the next crossover is between the mid-range and the tweeter. Not exactly certain. I know I researched it, but at a certain point, I'm covering up the mid-range, and it's not making much of a difference at 6.5. If I go down to 5, let's say. If I go down to 5, it's not even making much of a difference. Small difference at 4. A little bit larger difference. I want to say somewhere probably about 4 kilohertz. And I'm going to sweep it up to, let's say 7. And covering the tweeter, it's definitely a large difference in signal, covering it with a plastic cup. So we can be fairly certain that there's no impedance issues with most likely the crossovers and the particular drivers for the mid-range and tweeter on this unit. So I'm going to repeat the same thing. Just show you a visual with the camera. A little better with the phone maybe. Whoops, don't want to zoom in that much. You can hear that guy buzzing in the. 6 even. About 430 hertz, since I got that set to 10K. That cup is starting to buzz, so it's starting to hand off the signal in the crossover at about 400 hertz. So if I take it up to 6, there's really little or no signal difference putting the cup over that one, but there's a large enough difference here where you can tell that the tweeter is working. So I'm just going to repeat that on the other speaker as well and record things just to make sure that all the internal components are fairly well matched and not damaged too badly. So I'm going to go off to the next part of using newer technology in order to do the testing on the speakers. We are going to go to new school technology. I have in my possession the Dayton Audio DATS version 3 I purchased a while ago with the sole intent of using it for occasions like this, for measuring impedance and does all sorts of fun stuff for speaker design. Not only that, but you can document it, save it, and do things in a measured, quantitative, calibrated fashion to find out if you're having problems or if you're having success and failure, let's say tuning a speaker box or something like that. But in the meantime, I'm going to switch over to a screen record view. Which will give a little better view of things. Get rid of this guy. And I have the speaker serial number 04 hooked up at this point. I'm going to clear my Control-Alt-W clears your workbench. So we got to do a Control-Alt-W. Once I get back here, Control-Alt-W. And this has a feature called an impedance sweep, which you can set your impedance upper limit for 20 ohms, your lower limit set at 1 ohms, high frequency 20 kilohertz, low frequency is 5 hertz. And we are going to activate it. A very quick process. And it is done, and you can see we have the sweep on the resonance peaks about 50 hertz from the woofer. In the enclosure, we have one around 500. I'm suspecting that's more of the crossover function, if anything. And then maybe about 4K or so, there's another 4K, there's another dip in the impedance and a change in the phase as well, because it's measure phase angles. So that's probably the mid-range to high frequency handoff on the crossover. So I'm going to change my speaker connections, save that view as a file, and compare. This way I can measure and then compare the two files together. Make sure my switches are clean as well. And both set to 0 dB. Pardon the poor recording quality on the audio. Okay, we are set at speaker serial number 03, but let me save this first. We're going to export impedance data. That's formatted. We're going to call this AR1104. I'll put a date on it. Okay, and now we got to do Control-Alt-W to clear the workspace, and we will run an impedance sweep on serial number 03 speaker. That's that quick, and if you notice we have our peak around 50, another one around 500 for the crossover, and then a little bit different phase dip, and definitely a larger dip in the impedance on the tweeter on this one. So I'm going to do a save on this file. View, save the memory. Oh, I don't know why it didn't give me this before. Alt-1. I'm going to also export the impedance data on this one and call it 03. Oh, well, possibly I don't know if I can load the other memory. It might be easier just to resweep for. Change my connection. Oh. Okay. I will Control-Alt-W on this one. Oh, might have saved it in the background. Let's see. It doesn't overlay. Good. Well, if you can see, things are fairly comparable between the two, so there should be no major malfunctions, so to speak, between any of the components in the two speakers. They're both behaving about the same. I checked the mid-ranges. I checked the mid-ranges and the tweeters, and in the 03 speaker as well, they behave pretty well, exactly the same. And seeing that the measurement values are this close, I'm going to make a good guess that nothing's damaged, but the next step is going to be to open the sarcophagus and see what awaits inside the tomb. I'm curious to see if there's going to be any moisture damage or what, in fact, if anything else might be apparent once I get this guy open. So that's going to be my next step. Okay, I am back, and we are equipped with things to get the woofer apart. And I tell you, just looking at this thing, I don't know exactly the descriptive adjectives to to use to talk about what was done to this. It's hacked, bodged. There's a bunch of things you can call it. All I know is it's something that should not have happened. I'm going to find the proper bits. They were using some of the original, it looks like, hex button head bits, which is nice. So they did go through the effort of lining three of the holes up with that. I'll probably have to source some more hardware to replace that, seeing a lot of that went bye-bye. Yeah, the fact that this isn't unmolested is good, but it's bad, because I think it might go about saving me money in replacing a driver. Now, granted, it won't be the exact replacement driver, but I think I sourced one. I just have to make sure measurements match. As far as physical dimensions, I might have to do some modification. I'll have to do some modification to the cabinet, to the front of the cabinet. There's no getting around that. Oh, this is something I'm kind of going to see what happens here. This speaker is very, very light. It's It is an 8 ohm made in Taiwan. And it's destroyed beyond usable belief for one. That's cute. If you look at the terminals for the wires there, that just kind of... They cut some off of this one to get the one. Pretty comical. I don't know if this is... I don't think this is original anything. I don't know what it is. The fiberglass will not be moldy. It's got to be, that smell has to be coming from this particular fabric. And it's got some really weird smell. I don't know exactly if this even belongs in here or not. I never heard anybody talking about anything like this, but it's got a large amount of loose fiberglass. I should get a container to dump my fiberglass into. I was ill prepared. Luckily, I do have something to take all the offending, itchy stuff and put it in. My intention would be to get rid of this fiberglass and probably put some batted polyester fiber fill on the sides. What might even be better too is to put some sort of sound deadener, some adhesive sound deadener, and then start putting in some fiber fill. But the good news is this doesn't look like it had wholesale damage to it. It's funny because whoever did the modifications chose to take the speakers and a majority of the fiberglass out, because I have paint, black paint on the surface. I doubt if that was factory. Could be though, you never know. Boy, the fiberglass got stuffed. I'll have to get a little closer view of the crossover. Get some better lighting on it. Fiberglass really got stuffed in here. I haven't heard many people or seen many posts about complaints about the crossover network on this. It's besides possibly checking the ESR and the capacitors, seeing that these speaker capacitors on crossovers for the most part lead a fairly docile life, let's say. They only have AC voltage applied to them, and usually capacitors that handle AC, like motor start or motor run capacitors and air conditioners, usually have a pretty good lifespan to them. I'm going to speed things up, and we'll come back to after I get done picking all this stuff out. I'm done with most of the cleaning, so we can maybe get a better lit view of the crossover network in here. There really isn't a lot to look at. Some of this fiberglass, I tell you, I think they put the fiberglass in immediately after they secured some of the components in here, because it was hot melt glue everywhere. I could go through and check the resistor values and the coils, but it's really doesn't. I'll measure the capacitor. I'll end up measuring the capacitors as I go, but it doesn't look like a great need to do any work to the crossovers. I don't think they're probably behaving as well as they're going to. Excuse me. Switches, I could possibly get some deoxit in from the toggle end in the back, manipulate those, and I can consider changing the connections to a discrete banana 5-way post. It's got a screw, I guess, going screw. Oh, geez. Something getting to me probably to smell it. That one cloth that's in here. It's got a screw going back to through the back of that board that is apparently secured fairly well. Everything. So weird the way they mounted that board. They have most items on here not easily removable. If you look, it's got screws through the back side of the board that the crossover was built on, coming up and securing the coils that has spring clips on them. And once they're in like this, you can't really run the hardware back out. This guy is held on with a cable tie that you really can't replace. So any unattachment, reattachment, and that board is probably hot melt glued to the back of the cabinet and pressed on well. So you're not going to get that particular board off easily either. They've got some moderate bracing going on here. There's a chance that if it doesn't interfere with the magnet, another brace could be installed. Either some angled bracing to the back or some cross bracing to cut out a little bit of cabinet resonance. I wouldn't worry about top or the bottom resonance as much, but putting in some sound absorbent dampening on the inside might also help as well. So it's a fairly cheaply built cabinet, and the thing I have to concern myself with is the speaker opening. 5, 6, 7, all 8 original T-nuts are in the proper position. And I'm not, don't really have a proper measuring device, but I'm going to have to measure my span from hole to hole, because that's going to verify my ability to put a different speaker in here easily. It's kind of strange that they have the front is a 3/4 inch thickness, more likely than that, but they routed the lip down to a narrower diameter. Now that's going to have some effect on the woofer. You almost would have liked to see that reinforced a little better, and that's something I might look into. We can always add some reinforcement on the back side of it, glue some on, maybe either leave these T-nuts in place, attach some other wood to the back side with a little more bracing. There's a little bracing on the back side of this lip that goes across, so that's a good thing. There's nothing at the bottom here, so this panel could resonate a little bit. Well, some improvements could be made to the cabinet in general. I mean, these are, as with anything else, although it was designed for quality, it was also built to a price point, so you're not going to get the best build and everything. And manufacturers rarely show you the guts of all items like this when they go to send them out the door. But this is the chance you take when you buy something. You get what you get, and in this case I got the chance to play substitution speaker with something that'll definitely work better than this 8-ounce guy here, or 8-ohm guy, and I don't know I don't know if it's even worth. I just don't know. I just don't know if this is even worth reusing for in anything else. It's that bad. It's kind of funny that somebody just. It's a shame. It's a travesty. It's a catastrophe in some ways, but it gives me the opportunity of something to play with and not spend too much money doing it. So we'll get back to doing a little more research on my choice for what I'd like to put in here in a little bit. And I was just going to go over with you the view of both gutted cabinets and the result of said gutting with all the loose fiberglass. I did notice a few things about this. I was lucky enough where this particular cabinet did not have any type of moisture damage or anything in it, and the crossover is about the same build quality. Because seeing that they're consecutive serial numbers, the thing I was curious about this is the sides of both of these cabinets. I need a little better lighting here. I can show you. Sides of both of these cabinets appear to be some sort of plywood. It's definitely not fiberboard at all. So they must have done that to control any type of ringing or resonance on the cabinet. It's just interesting that they use part of the build, and then looking at some of this stuff, it's kind of funny. Whoopsie, turn it off. If you look closely at the resistors, there is enough fluff on from the fiberglass where it must not have been a hot melt glue. It must have been some sort of slow curing adhesive where they got that board on there. Said the board was stuck, but then the adhesive was so soft enough to have the fiberglass stick to it. So I'm going to go over what I'd like to use for replacement woofers and compare some measurements on the stats of the woofers versus what might actually fit in this cabinet and what modifications I might have to do to make that work. So here's what I have going on. I found online a neat little online loudspeaker enclosure calculation where you can enter in all your Thiel small parameters and hopefully get some advice on how the speaker will perform with that enclosure. And it's got 3 variables also. It gives you for a vented box with a vent that it self-calculates, a closed box, totally sealed, and then so this will kind of tell you if you enter your vent diameter, and then it'll tell you your other parameters. Closed box, it'll give you your performance for that, and your own box volume. You can enter the volume of the box, and right now the interior value of that box is about 41 liters. And in order to get it as a sealed box, you reduce these two values, your vent diameter and your vent length, to as small a number as possible, and then it simulates a sealed box. And I'm going to go off of the measurements off of a speaker that I found at Parts Express. I happen to find this falls under the classification of subwoofers, and I'm looking at this speaker. I'll show you exactly why I'm looking at that speaker. Here is what should be the replacement from Simply Speakers, the full out replacement, matching model number, the frame flattened on the side. $174 for the first thing. Number 2, availability, out of stock. I put on the waiting list, but there's 2 things with this. For one, it's the waiting list could be anywhere from 2 weeks to 2 years. You don't know how long it's going to take. Things nowadays with the supply chain crisis that we have nowadays, and it seems like a general lack of anybody wanting to do anything in a timely manner anymore. So I'm not going to rely on this, but it's got some specifications on the speaker itself. It's excuse me, depth of voice coil, 2-inch 4-layer magnet, 40 ounce. It doesn't. They don't give a full list of a data sheet with field small parameters and other things. They're just expecting people to need these, buy them, drop them in, pay for them, get them, drop them in, and be happy. I'm not sure how close these are even to the original manufactured speakers. I mean, they have a part number stamped on the back. Who's to say how accurate they built the design of these guys here? I did some other reading, I'll show you a little later, on some of the design parameters of these speakers as far as originals that were tested by other people. One of the things I read was that the original woofer had what would be considered a half-inch, 12.5 millimeter of linear excursion in the woofer. Now that doesn't mean that's limited to that. It could go further, but it gets into a non-linear fashion at that point, and then what happens is it introduces distortion. If you drive it too hard, I mean, having it in a sealed enclosure helps dampen some of those effects. It's got a low resonance of a free air resonance of 22 hertz, which this is a subwoofer. It does have, on the listed specifications, where do we go here? Bolt circle diameter 11/6. That's right around the same bolt circle diameter as the existing original speaker. Power handling is 250 RMS, 500 peak, impedance 4 ohms, which is a lot better than what was in there. Here's the one that really gets you. As far as looking at all of the subwoofers I looked at, none of them seem to go over 200 to 300 hertz on the top end. This one is shown as going out to 500 hertz. And the sensitivity fits in about with the sensitivity of that speaker. And here's got all the field small parameters, your resonant frequency, your DC resistance, voice coil. So that lets you plug things in. Tells you the composition of things. Here's the one kicker that's going to get me. The overall outside diameter of the basket is 12 1/8 inches, and that indented part that's routed into that face of the cabinet is only 12 inches. So I'm going to, if I do purchase these, I'll have to work that out a little bigger, and then I also have to router out the spots that have the flat areas in them and make it a full round circle. Baffle cutout diameter 11 inches. That I didn't check that, but I'm sure that can be enlarged if needed as well. And the 6.3 inch mounting depth shouldn't be a problem. Number of mounting holes 8. For the optimum cabinet size, this lists a sealed volume of 1.2 cubic feet. So we're going to the sealed resonance should be 40 hertz. So what I'm going to do is go back. I've plugged all the parameters of this speaker into that calculator. Everything that I could find, putting it down to an enclosure size of 41 for my own box. And if you let once I run this calculator, the two we want to pay attention to are the parameters for the closed box and your own box. Because your own box will be a sealed 41 cubic. On a closed box, this would, at the desired QTC of 0.707, this will give you the size box it thinks it should be in. Going to calculate it, and there we go. So a closed box without filling, the size it calculates for the best response would be a 47.31 liters. Your own box, which is the size that enclosure is 41 liters. Now here's some of the parameters it came up with. So interested, a vented box, it actually brings it down a little lower in frequency. Both of these curves are flat to, I want to say, about 40 hertz. There's, no, that's 50 hertz. 40 hertz is there. Starts to drop off at 30. Maybe it's 2 dB down at 30. At 20 hertz, pulls about 10 dB down. Step response is interesting. This is the information that tells you how the driver reacts when given a quick pulsed signal. How it will peak to the positive, rebound to the negative, and then flatten out. And both the closed box and your own box parameters are really close. So really that size, according to this calculator, the size between the 47, that 6 liters of size value really shouldn't make a lot of difference in the performance of this woofer, to the frequency response, to the step response. The group delay, I'm not exactly sure about what exactly that does for you. All I know is it's didn't calculate some things right, possibly because it didn't have the right parameters. The voice coil impedance, which is basically the resonance of that speaker in the enclosure, the closed box that it came up with is a little more volume, so it's just a little bit lower on the resonant frequency. But those both came up, that's 10, 20, 30, 40. It said right around 40, 44 hertz. And that's close to what the designed original woofer is. So in a lot of the parameters, it should match up fairly well. So I'm going to be happy with that part of it, I think. I just have to cram it in here. And here's some of the design specifications on that particular woofer from Parts Express. There's a frequency response. It doesn't say, I'm not sure if this is free air or in a box. I'm going to presume it's free air because it's going down. It's 50, 40, 30, probably about 20 hertz right there, 75, 85. Could be in a box, don't know. But the main part is the response goes out to at least 4K. Oh, that's 4K. We aren't worried about K. We're worried about hertz. We want 500 hertz. It gives you a very flat response, and I don't know if you remember, but that mid-range and the crossover start picking up and crossing over below 500 hertz. So this should meet right up with it. So my big thing is the price point of these speakers is the most desirable part of them. That and they're available. For one, they are currently on sale at $59.98 a crack, and they're in stock. You can't beat that. I mean, they're going to, odds are more likely than not, work very well on those enclosures. They're not as, like I said, will they be as good as the stock? Probably not. But the thing is, you can't get the stock ones, and I'm not going to, really don't want to sit there with empty cabinets and not have the ability to listen to these darn things, and knowing that, like I said, these speakers have already been molested, bastardized, whatever you want to call it, and at this point there's kind of like no turning back easily. And even if I did, if I wanted to make them look stock, I would be involved filling in all those cracks in that expanded MDF and plywood and trying to sand down that veneer and trying to get a good finish on them, and I'm probably just going to leave them black and not worry about it. But I just want to make some performance improvements from the condition that I got them in, get them close to a performing stock configuration, and sit back and enjoy listening to them. So that are my plans for these speakers currently. I'm going to leave you with something else I'm going to get to in 1 second. Let me pause the video. I was doing some surfing for as much information as I could find out about AR11 woofers or any of the 12-inch woofers in the Acoustic Research line of speakers. And the classic speaker pages discussion forums had a few links with some varied information on different woofers and the replacements. And here this person, Giorgio AR, has a post of working with some of these, and these are the original AR 12-inch woofers, and these are some Tone Gen 12-inch woofers that are what would be the replacement manufacturers. He's got pictures of them. He's got pictures of the backsides. This is interesting because the AR one, this looks like it actually almost, it looks like it has like a vent in the back of the magnet assembly that this one doesn't have. If that's the case, if that goes all the way through and it's vented somehow or not, I'm not sure. Kind of strange. But he's got all sorts of pictures and posts on things. I'm going to put these links in on this video here. Also, the difference in the colors of the seal, or the beauty ring on the basket, and there's a couple other posts that go into more depth on information for the free air resonance of the original speakers. There's one person who was posting, let me get to that one. Okay, I found a post on AR11 woofer measurement reform repair by Pete B, who seems to have done a lot of work on acoustic research speakers, and has amassed some information in here. I don't know if this AOL link works. It's back to 2005. Let's try it. No, it does not. Yeah, AOL servers are long gone in the past there. So what do we've got here? He's got some measurements he took of Thiel small parameters. The free air resonant frequency 15 hertz, the voice coil impedance of 2.49 ohms. So that's a bit different than a lot of things. But in the enclosure, the enclosed resonance is 44.5 hertz. That would be really close to what's in there, what that new speaker would perform like in that enclosure. Got more AOL links, and somebody had an interesting link in one of these posts. I don't know if I can find it. But there's all sorts of good information on these posts. Here we go. You've got must have been done by a person in Italy someplace, because it's a curva di impedenza on an AR11 of October 1975. So it has the impedance curve, basically the same thing I ran on the D8 and the Dayton Audio DATS version, and it shows the peak there for the woofer just below 40 hertz on a Mark 1. So I'm not sure what that one is. And then the crossover frequency peak it shows, and then the rising peak on the tweeter. And that's very similar to the curves that I produced with the DATS version, except for the resonant frequency and the speaker. This one was higher because it had a 8 ohm totally wrong woofer for that enclosure. So that's the information I have for now. I'm going to go off and work on a few things as far as trying to get my hands on those replacement woofers for one. getting them and then seeing how they're going to fit into the cabinet, what modifications I need to make. And then I'm going to go through a few things with some work on the cabinet itself. I will check the crossover components. They're probably functioning just fine, but I'm going to go in there and qualitative measure everything anyways, just to make sure that it's all within parameters. And then I'm going to start trying to get the darn things into a condition where I can hook them up to an amplifier and use them. And of some more interest, on one of those posts on the Classic Speaker site, there is a picture and a listing of an AR10 Pi Mark II, which looks curiously like the AR11 upside down. It looks like exactly the same enclosure, except for the fact that the blank spot that's the base on the 11 that's on the bottom is on the top, and it's really a weird design difference. But here's a view of all its components and the polyester fiberfill foam that was used. And there's more information as far as the free air resonance and some components, but it looks like the exact same drivers as the AR11. And there is also some information that this person took along with the impedance of the AR11 enclosure. He also has the information for the AR10 Pi Mark 1 and Mark 2. So Mark 1 is in 1976, and here's some information on the AR10 Pi Mark 2 in 1979. So there's a lot of interesting information to peruse about these particular speakers, and it's anybody that's likes playing around with loudspeakers and designs and trying to rebuild or improve stuff. Sometimes it's amazing what you can and can't find, and there's some crossover listings as well for some of these. I found that all sorts of interesting and fun information. So again, I'll leave the links. This is at the website of the Classic Speaker Pages discussion forums. So I hope you enjoyed the content for this video. I don't know if I'm going to return my next video with something on this. I might be up to something else. I've got a lot of other stuff going on. But in the meantime, if you like the content, please feel free to give a like. And if you'd like to see more content like this, please feel free to subscribe. And I will hope that you stay well, and we'll hope that you come back soon for more viewing. Thank you. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.